we left off exploring the Raspberry Pi Model 4 hardware, and we're going to pick up with exploring the Raspberry Pi Model 4 accessories. There's only 4 components needed to safely experiment programming embedded systems on the Raspberry Pi. We need a case to protect the Raspberry Pi circuit board from static or physical damage, a USB Type-C connector power supply supplying 5 volts at 2.5 amps, micro SD card holding the boot operating system at least 8 gig in size. We'll be supplying 32 gig micro SD cards, and you'll need a Cat6 network cable for gigabit Ethernet interface. We can use the display, keyboard, and the mouse while experimenting to make things easier. There's no need to make things harder, for sure. And so by being able to access the operating system through the command line, we can discover the operating system's configurations, particularly network configurations, and we can also modify network configurations at the command line right on the user interface of the device. So the Pi comes with a Raspbian GUI, but a lot of the work that we'll be doing will be done through a terminal session or a command line session, a shell operation in any case. Now, we're going to concentrate, although that's easy, we're going to concentrate on programming the Raspberry Pi as a remote embedded system. So that's what we want to get our experience in this class doing. So PuTTY is an SSH client for Windows, and PuTTY uses either a serial COM port or an Ethernet port to connect to a remote terminal or console session. So using an SSH client with a COM port, it's a common way to install the initial configurations on network equipment before it's initially deployed. Firewalls, switches, routers, things of this nature. It's very common that when the device comes in, you download the configuration from the device it's going to replace. For instance, if you were doing like a hard cyclic hardware refresh, you might have 200 or 300 routers that have to be turned over. So you need a good process, a good smooth way of doing that kind of work. And by console session is a good way to do that. So you're doing your maintenance remotely in any case. So you're going to remote in to a remote router or switch or remote network device. You're going to download that existing configuration. You'll massage that configuration to meet the new hardware requirements, and then you're using simply a power cable and a console cable. You'll power that network device up. You'll console into it from your laptop, and you'll load that configuration, and you're done. That unit's configured, ready to be deployed. And in that case, you could have 200 or 300 of them. Have teams configuring and stacking them up, and other teams deploying them. And when you get them on site, sometimes they don't work. And so being able to console in while you're out on site, just bam, plug it in, console in, there's your stuff. It's all right there. No fancy equipment needed to manage that embedded system. Now, other software that we can use besides a console cable, because as we'll see, we're not going to actually get a console cable with the Raspberry Pi. We'll see that. But other software that we can use in doing network discovery network configurations all of the Raspberry Pi. If we didn't use the display and the GUI and just sort of cheat, you might say, and get in there and get that information out and use it, we might have to have other ways of discovering what the initial configurations of the Pi are, since we can't console into it. So you can power up a Pi. You can make sure it's going to come up in DHCP. You can make sure it gets a DHCP address, or you could come up and have a locally assigned address if DHCP was not available, like Microsoft's 169.254 numbers. Something like that could happen. But anyway, to be able to set up a console session, you've got to know how to make that connection. And so network discovery tools are a good way to find that information out without actually being able to get into the equipment itself. You're going to read the network traffic to find out how that device is configured, and then with that knowledge, you're going to console into it. So, other software that we might use in network discovery to find out where your Pi is on the network is Wireshark, which is a network sniffer. It sniffs traffic on a local interface. And another piece of software that can do that is Nmap, which is good for both. There's Nmap versions for both Linux and Windows, and there's also a Windows GUI version, which is the one I recommend, and I'll show you, and that's called ZenMap. So we'll also, there's an important accessory that you're not getting. It's the console cable that I was talking about. It's a valuable piece. You should really have one, and it would make your life working with the Pi easier. And that's, so if you propose to work more widely with the Raspberry Pi, the 3-volt TTL interface is especially handy. It allows an immediate and simple method to establish a console session to your Raspberry Pi. Also, ancient SneakerNet still works. It works well, and and many times the SneakerNet is a lot faster. So this USB to TTL 3.3 volt UART cable, it's an active cable, which means it has a chipset inside of it, which bridges the 5-volt USB serial data to the 3.3 volt serial UART located on the RPI GPIO. Now, there's a driver that's required by this interface, and that driver creates a new COM port, a virtual COM port, or I guess in any case, it's a new COM port. It creates that COM port on the local host on your laptop, and this interface cable is not going to be provided in this class. So a USB storage device not only expands the RPI's storage, but it also acts as a SneakerNet, which allows you to move data from your local host to the RPI and back again just by walking it over there. Hence SneakerNet. Now, how to protect your Raspberry Pi. This is why you don't get your Pi until after you answer, write me a paragraph telling me that you know how to shut down the Pi. Do not shut down the Pi by unplugging the power. Do not apply power to the Pi when it is out of its case. Do only connect low voltage devices to the GPO. Only connect TTL 3.3 volt devices to the GPIO. Do not apply power to the GPIO with the Raspberry Pi powered down. And be cautious and aware of the pin numbering on the Raspberry Pi GPIO. Do not mistake pin 19 for pin 21. The main takeaway should be the requirement to gracefully shut down the Raspberry Pi. Don't just unplug your live Pi, lest you suffer data corruption on the boot drive. So, and also, if you do work on a powered up Pi out of the case, which I do, I work on this mat right here, and I solder on my Raspberry Pi, but you just need to make sure that if you're going to do that kind of work, that you always work on a static-free and insulated area, and an anti-static mat is an excellent way to achieve that. Now, you need to look for these things to be on your midterm exam. This is what information you're going to be responsible for. The Raspberry Pi is suitable for education and smaller personal projects. You should be able to explain why. Embedded systems have become ubiquitous during the information age. You should be able to name common items which use embedded systems. Human interface design for embedded systems is important. You should be able to discuss different interfaces used with embedded systems. The Raspberry Pi Model 4 is a full-featured general-purpose computer. You should be able to identify the hardware systems. The Raspberry Pi is an electronic device. You should be able to operate your Raspberry Pi in a safe manner. Now, the following resources are useful. The first one, exploring raspberrypi.com, is a repository of textbook resources for your Raspberry Pi textbook. There's a Raspberry Pi forum. You can get lots of advice. You can find people that have run into the same problem that you ran into, and they already have the solutions out there. There's a download site for the PuTTY SSH client for Windows, a download site for Wireshark Network Sniffer for Windows, a download site for ZenMap GUI Network Mapper for Windows. You should become familiar with the use of the Windows and Linux command line netstat, which displays network traffic on a local network interface. And you should become familiar with using ipconfig in Windows and the Linux command line ifconfig, which displays local IP configuration information. Now, let's look at some of these applications and these network discoveries apps that I was telling you about. Okay, let's start off by looking at let's look at some command line stuff. Let's start out with something fairly simple like netstat. There we see netstat-a displays all. So let's look at what we're seeing here. That's the internet's net number, so that means everything. kind of how the local machine, well, not listens to itself, but that is a local address, and the foreign address, note, is Stonefly, which is the local machine. 127.0.0.1 is the local loopback. Again, that's local, and Stonefly is the foreign address. Here we have 169.254 number. That's a Microsoft auto configuration or self configuration IP address. Oops. 192.168.1.51. This is the local host. This is some IPv6. This is similar to this right here. That's IPv4. IPv4. This is IPv6, but it serves the same function. And then down here you see a similar thing in UDP to IPv6, and then again the IPv6 similar, but now for UDP packets, and another IPv6 address. Now then, I've identified every address on here as being a local address, and I can do that, I can verify that by looking at IP config, again, all, and we see Stonefly is a local address. My DNS suffix is att local.net, so I'm a member of the local ATT domain. Right here, this loopback adapter for MPCAP, here's where I pick up the IPv6 address. Here's where I pick up that 169.254 address, and here's the DNS IPv6 DNS servers that it can use for resolution. So that's the IPv6 traffic that we see on the network. That's totally coming from this loopback adapter. Ethernet adapter 2, that's the hot Ethernet adapter, the one we're using. There we see it's connection specific address. We see that it's a surface adapter. This is the MAC address. That 1.51, that's its local address. There's the gateway, and the DHCP server, and the DNS server. And we'll drop down to the last adapter. It's a Bluetooth adapter, and it's disabled. Or actually, it's not disabled, but it's not connected, so it has no IP address. So, using these two, I can use this information and this information to see what doesn't belong, what is out of, what is a foreign address, right? So I can start looking through these foreign addresses here to try to locate traffic to my Raspberry Pi. And another way to do that, perhaps a simpler way, would be simply to scan your local area network if you thought the Pi was on it, and it probably would be if you were connected to your local host with an Ethernet cable. But we do a quick scan of this 192.168.1.0 for a 24 subnet CEDAR, and maybe 10 seconds is all it'll take to scan all 250 addresses. 256 addresses in 21 seconds. Well, I was half right. And we've got 20 hosts up. And so these are the hosts. These are the hosts on my local area network. these are switches. That's the gateway. My cell phone. And the last way is Wireshark. We're going to pick up our hot, it was Ethernet 2. This is, we're seeing some of the loop backs carrying traffic. We want to look at the traffic on Ethernet 2. I fired it off without a input filter, so it's capturing all traffic that appears on that connection. Let me just stop that. And you can see these are various devices showing up. These will probably be, well, these are resets, but the resets take the form of this is resets to the local host from some other host. This is from a switch. That's also a switch. So, and that's a switch, and I don't know why we're getting these resets, but that doesn't matter. It's something to get sidetracked on. But again, you can use this software to sniff your network and try to locate your Raspberry Pi IP address. That concludes the lecture for this period, and is the end of Chapter 1, Hardware. Next week we begin Chapter 2, the software portion. Be sure to check Blackboard for handouts and other information, and have a nice day.